So we're going to be focusing on 3 questions about motor oils. What do oil weights actually mean? Do thinner oils improve fuel efficiency? And can thin oils effectively protect an engine? So let's start off with oil weights and what these numbers really mean. Ensuring the proper viscosity is the single most important criterion of a motor oil, and the higher the viscosity grade on the bottle, the thicker the oil. But these numbers are also temperature dependent. So for example, here we have a 10W30 oil. The first number, 10W, W standing for winter, represents this oil's viscosity grade when it is cold. The second number, 30, represents the oil's viscosity grade when it is hot. Because there are 2 different numbers here, this is called a multi-grade oil. Now, since the second number is larger than the first number, does this mean this oil gets thicker as it heats up? Well, no, it just means it behaves like a thicker grade oil, an SAE 30 grade when it's hot, but it behaves like an SAE 10 grade when it's cold. Here's a quick demonstration. So in this cylinder, I have 100 milliliters of 5W30 at room temperature. And then in this cylinder, I have 100 milliliters of that same exact oil, 5W30, except it's been sitting in the freezer overnight. So I'm going to drop a ball bearing into each cylinder, and whichever one hits the bottom first, that's the thinner fluid. I expect this is going to be messy. Ready? Beautiful. As you can see, the cold cylinder here with the cold 5W30 took significantly longer for that ball to reach the bottom. So as oil heats up, its viscosity decreases. If you look at a graph of temperature versus viscosity, it will look something like this. So in blue, we have a 0W40 oil, like what's found in the Corvette, and then our red line is a 10W30. And so what you'll see is at cold temperatures, the 10W30 is thicker. However, as that oil reaches operating temperatures, the 0W40 is thicker. And both oils continue to get thinner as they increase in temperature. So how does an oil behave like different grades depending on temperature? Well, typically you start with a low viscosity base oil and then you use additives, specifically viscosity modifiers, to change that rating as the oil heats up. Now, as far as what contributes overall to the viscosity rating, and it's of course dependent on what this rating is, but generally speaking, the cold rating is more dependent on the base oil that is used, and then the hot rating is going to be dependent on the additives like viscosity modifiers. Now, perhaps you've noticed a trend in the automotive industry in that these numbers keep getting lower and lower. And in fact, there are production cars sold today with 0W16 engine oils. So why are they doing this? Well, generally speaking, the lower these numbers are, the better your engine efficiency is. And this is an industry where efficiency is everything. Now, can they still protect at the same levels as thicker oils? We'll tackle that question a little later on in this video. So why are thinner oils more efficient? Well, basically it comes down to friction. If you think about dragging your hand across a surface of honey, it's slow and it's difficult to do. If you think about dragging your hand across a surface of water, well, it's easier and it takes less energy to do so. The same idea applies to oils, which act as a protective barrier between 2 surfaces. But of course, you still have friction between the metal surface and the oil. The question is, how much can you actually increase efficiency by? With the obvious disclaimer that it depends on many things, like which viscosity grade we're comparing versus another, what engine we're using, what the operating conditions are, and so on. But I've seen studies showing that going from a 30 to a 20 could result in over a 1% increase in efficiency, as well as going from a 20 to a 10. If you look at fuel economy testing, lower viscosity grades are required to meet more challenging fuel economy limits because it's known that they improve efficiency. Based on these fuel economy tests, you can derive the benefit of a 0W or 5W20 over a 5W or 0W30 is in the 0.3% to 0.5% range. And the benefit of a 0W or a 5W30 over a 10W30 is in the 0.2 to 0.7% range. Now, fighting for a fraction of a percentage improvement in fuel economy may not sound significant for those who aren't working within the field of internal combustion efficiency. But when you consider how efficient today's engines are, gas engines with peak efficiency around 40%, raising that number to 41% is a very difficult problem to solve, and oil can help play a role in solving that. I understand that fuel efficiency isn't everyone's favorite subject, but I have to admire the very challenging problem engineers are faced with and the solutions that result from tackling this problem. So the big question, can thinner motor oils effectively protect an engine? And I've asked this question to a fair number of powertrain engineers, and I discussed it with Mobil 1. And with modern engines, engine wear is usually not a limiting factor. Companies have done an extremely good job of figuring out how to make the internals of engines last. What's more challenging is improving fuel economy. And since you can do this by moving to thinner oils, companies are doing it. I think it's worth understanding how wear happens so that you can better realize how thinner oils can still protect engines from wear. You simply have oil between the moving metal surfaces, and as long as your oil pump is maintaining proper flow and your oil is in good shape and being changed at regular intervals, you won't have much metal wear. Now, there are instances, like when you start up the car, that you won't have that full oil film thickness between the moving parts available. That's when anti-wear additives are useful that stick to metal surfaces and minimize wear at startup. There's also something very interesting that happens with your pistons and cylinder walls. So you have oil sprayers that are coating these walls to protect this piston as it moves up and down. And as long as that piston is moving, it's protected by that barrier, that film of oil. However, the piston isn't always moving. So when it reaches the very top, it switches directions. And so for a brief moment, the piston is stopped. And then when it reaches the very bottom, again, it changes direction. So for a very brief moment, it's not moving. As an analogy, think about a person sitting on water skis in about a foot of water. So if that person's not moving, well, then their water skis are resting on the sand below them beneath that foot of water. But once the boat starts to pull them, those water skis pop up on top of the surface. For the vast majority of your engine, you have a high velocity between moving metal parts, and that high velocity keeps the parts floating on an oil film, preventing wear. Now, does that mean you should simply go out, buy a thinner oil, and stick it in your car? No! Your engine was designed and validated using a specific oil, verifying that the engine had an acceptable life and durability, desired fuel economy, and met an acceptable oil drain interval. You should always, always, always use what's recommended in your owner's manual. But let's have fun with some hypotheticals, which again, you should absolutely not do. This engine uses Mobil 1's 0W40. So what if you put 0W20 in it? Well, that would probably be bad. Higher performance engines will see higher loads on the engine parts and may need that higher viscosity for a more robust oil film. You might have too much leakage in the journal bearings if you used a thin oil. So as a general rule, going lower on the hot rating number is a bad idea. But what if you went thicker with the hot rating? Well, generally speaking, it's not terrible, though again, not recommended. In specific cases where a car sees a lot of track time and the oils are getting into much higher temperatures, sometimes you'll see cars recommend thicker viscosity grades when you're on the track to make sure the viscosity is still high enough at those higher temperatures. Now, what if you went lower with the first number? So say your car recommends a 10W30 and instead you put a 5W30 in it. Well, if you look at the overall viscosity range of each of these different oil grades, you'll see that the 5W30 range falls entirely within the 10W30 range. So really the engine wouldn't be seeing a viscosity that it hasn't seen before. But if you went the opposite direction, say your car recommends a 5W30 and you put a 10W30 in it, well then at cold temperatures, it's going to be seeing a much thicker oil, and so you could run into cold cranking and oil pumping problems. So the definitive rule, use what the manufacturer recommends. If you use a higher number here or a lower number here, bad things can happen. If you use a lower number here or a higher number here, it's not as risky. Have I said it enough times? How many times have I said it? Use what your car manufacturer recommends.